Test. All right, everyone, how we doing today? Doing good? All right, let's see. All right, let me get my little doc cam. Finally got the music working. EE220D. Is it week 4? Yeah. September 17, 2025. 1. All right, so how's the lectures going? Good? Are we finally getting to a better state in the lectures? How's Dr. Zhu doing? Doing good? Y delta conversions? How's Dr. Pushkin doing? Anyone? Dr. Pushkin? Also the same thing too? All right, so it looks like everyone's on the same page. So let me see, what do I have here? Fall. Wrong lab. Let's see, UNLV. Look at all my documents. There we go, week 4. And turn this puppy off. So I got an email. Is this one of your guys' homeworks?
I sent you our homework. It was a PDF.
Yeah, it was a PDF, right? Let me see. And then I got this other homework. Does this look correct for Dr. Pushkin? Yeah. And then let me see. I think I downloaded it. I finally was able to get into their classes. Does this look familiar to what you guys are trying to do?
Yes.
Yeah, I finally got access. So now I know exactly what's going on. I can try to keep everyone on track. Let's see. Let me just check my phobia. We're recording. Test. Perfect. So before I go over the homework, I want to teach everyone a couple things. So we did go over LTSpice. Is everyone using that as a calculator? No, yes, maybe. To solve the problems. Hopefully we get to there, right? So one of the things I want to do is solve a simple circuit. And I think this was last week when someone was talking to me about this. Let me use a blue marker because I like blue. Plus, minus. Let's make this, let's see, let's do this. Do this. Do this, do this. And do this right here, another wiggly line. And then let's make this 10 volts. And then let's make this 100 ohms. And then let's make this 200 ohms. Have you guys seen this kind of problem in your homework? You guys like this circuit? Yes? No? What if I do this? Does that make you guys a lot more comfy? What's the voltage over here? 0. What's the voltage over here? 10 volts, right? At this node right there, right? So, someone was telling me, okay, we're thinking about time. Here's our time. I'm going in time. Here's time going that way. And we were at time, let's just say 0 is right here, right? And then this is -1 seconds, right? Right? So we're looking at a switch, and the switch is closing like this. I'm going to call this one a switch, right? And it's closed. It's closed on this circuit. I'm going to call this one loop 1, all right? So it's closed for all this time right here. I'm going to say it's like, actually, how do I want to say this? It's closed over here, or how do I want to say this? I'm going to keep this right here because I'm going to try and switch this circuit over here. What I'm trying to say is here is V1, voltage 1. I'm going to call this one V1. And this, actually, if I have a wire here, right, this is a switch. A switch is just a really nice wire that just switches around, right? If this is 10 volts, right, what's this right here? 10 volts, right? So that means at V1, right, it's going to be 10 volts before it's closed, right? It's just existing. Sweet, right? But now what I'm going to try and do, let's grab my handy dandy pink one. So I'm going to cut this, right? If I cut, it's not a good color. No, I don't like that. It's another color I have. Let's do red. Actually, I think that's worse. Do I have another marker? Let me check. Yes, I do. My friends. Use this aquamarine color. So I'm going to get rid of that. You see? That's because I forgot to connect it to power. Give me a second. Oh, fell asleep. Test, test. We'll check that recording later, huh? Anyways. So I just closed this switch. I'm breaking it, right? So if I'm breaking it to the point where it looks like this, here's my resistor right here, right? Just 100 ohm resistor, right? And I have this wire right here, and I just disconnected it, right? So let's do a refresher. What's the voltage over here? 0, right? And this is 10 volts, right? What's the voltage over here? 10, right? What's the voltage over here? 0, right? So everyone, tell me, what's the voltage over here? Why? So we just break the circuit, right? It's open, right? So that means there's no water flow. What's the current I here? 0, right? And then when we do V is equal to IR, right? Where R is 100 ohms, right? And then our 0, or current is 0, right? What's V? 0, right? So the voltage drop plus minus is just 0 volts. That's why this is 0. Does that make sense? So, okay. Now, we just cut this circuit, right? Now I'm about to do the following. We're going to connect that, okay? I'm going to call this one V2, right? We cut this at, let's just say, here's time 1, right? Or something like that. I'll just keep that closed. We'll think about it. At time 0, I'm gonna cut this circuit, right? Instantaneously, this V1's gonna go to 0, right? It's gonna go from this 10 volts down to 0. Is that correct? So we should be able to see some type of drop, right? And now it's closed, it's broken. It just goes on forever, right? Is that understood? However, we have this V2, right? Before, what was the voltage at V2? Should be off, right? It's off, right? 0 volts. But now I just closed it at times equal to 0, right? 0 plus. What's the voltage at V2? 10 volts, right? And then we just do like that. Does that make sense? So this is 10 volts, right? We have a current flow, right? What's our current? Easy? So let's just solve this problem. It's equal to 10 over 200. Cancel that out. Yeah, 120 amps. Does that make sense? You guys want to see this calculated in LTSpice? Would this help for your guys' homeworks? All right, let's check this out. So I have a little demonstration. There you go. Turn that power on. Plugged in. So we're going to recreate this circuit. All right. So I'm going to show you a new module. It's called the switch. Oh, I press P for components. You can also press this button right here, components P. And this is a switch that you can use. It's found in the library for LTSpice place. And this will act like your switch. But here's the problem. It's like a single action switch, so it just connects a wire. So it's not going to be like, oh, it goes to 2 channels. It's just 1 to 1. So what I'm going to do, let me show you an example of what I'm trying to do. So I'm going to instantiate this switch. Let's do a simple problem first. Resistor. Let me just do this. Let me see. Yeah, do I want to do that? Yeah, let's do this. Voltage. I'm going to connect this switch. Wait, hold up. Connect the switch. Boom, 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 boom. Guys like that? Do 10 volts, right? So there's a thing about the switch. The switch is a component that you need to start declaring variables for. So let me just do the following. I'm gonna put a reference to my switch. The switch needs to be grounded, as in like our light switches, they all have some type of ground. So if I ground this port right here is our plus to minus. I'll show you how to use this switch. Let me see. I'm gonna create a new wire called, type N for node net names. I'm gonna call this switch, I don't know, V switch, voltage of the switch. Does that look good, right? And then I'm gonna call this 100. Then I'm gonna call this one V out, right? Is that looking like a good circuit? Does that look good? So I'm gonna run this and show you what's gonna happen if you just do this. I'm gonna run this for, I don't know, 10 seconds. So it's asking, hey, I need a definition for this switch model. So all you gotta do is if you press this is gonna be your like commands that you start to define. There's one command that you'll learn to memorize for the next 4 years is the model. That instantiates, say, hey, we're gonna create a model here. And before I even do that, let me name our switch. I'm gonna call it our my switch. Does that look good? So now let me create the model. Dot model my switch. You like that? So this type of switch is of the family SW. That's, I guess, what it's looking like. It does have default parameters, but I'll show you how to actually control this. One of the parameters is our resistance when it's on. Are on. Does that make sense? And when it's on, right, the switch should be ideal, right? Should be just ideal wire, right? What does that mean for our resistance? It should be close to 0, right? So if I do 0, actually let me do 0. See if that works. There's another resistance. We need to define the off resistance, or off, the resistance when it's off. Let's choose a big number. Like that. There's another way of doing it. 1 meg. What does 1 meg stand for? 1 mega ohm. Good? So now there's another thing I want to teach because they haven't shown this in the labs, but I want to make this a thing that will be drilled into your minds. There's a threshold voltage, or like the switching voltage, and I'll define that as VT, our threshold voltage. Does that make sense? VT, threshold voltage. So this is basically, okay, what is our switch going to do? What's the point? What's the switching point? So for all intensive purposes, the default is 0. But I want to engrave this into everyone's mind so that it's not as difficult as it should seem. I'm going to put this at 0.5 volts. Does that look good? I'm not going to put the V there because I haven't tested that out yet. So now this is our little command. Looks really nice. We're going to instantiate it. Does that look like a nice circuit? Any questions? How do we turn it on? That's the next question. Let's turn it on with a nice little switch right here, or pulse. So I want to mimic a pulse. We're going to turn the switch on. We're going to throw it's going to go from 0 to 1 volt, and when it's at 1 volt, it'll turn on. Does that make sense? So initially, the switch should be off, right? Or we're about to open it. Or do you guys want to see it on to off? What do you guys want? Let's just show it closing. So I'm going to call this V switch. So this is the voltage. V switch is going to go up and down. It's going to be connected to here. Is everyone understanding when I said that this is connected to this? The labels make it easier for your eyes, unless you guys want to do this. Boom, boom. You like that? That look nasty. We don't want to do that. Control Z, Control Z, Control Z, Control Z, Control Z. So now let's actually do the switch itself. Go to Advanced. It's going to be called a pulse because we're going to do a pulse. I'm going to go from 0 volts, right, to 1 volt because our switching voltage is half, right? Does that make sense? Does that feel confident for you? So let's just wait 1 second before it does that. We're gonna see it at 0 volts, okay? 1 second. My rise time, we gotta go instantaneously. We can do 1 nanosecond or 1 micro. Or let's do 1 milli, let's see what happens. And then fall time, we're gonna do 1 milli. I'm just setting how fast it goes from 0 to 1. Does that make sense? And then I'm gonna have this switch on for, let's just say 5 seconds. Is that good? You like that pulse? All right, so what should we see? It's gonna be 0 to 1 volt at this point right here, right? I'm gonna simulate this pulse. So if I run again, my switch cannot have 0 on resistance. I knew it, because it doesn't like that. So I'm gonna do the following, 0.01. Is that clear? Because apparently it's like it doesn't like it when it's 0, because then it starts choking, saying, "Hey, I can't do this." So we're gonna have to feed it some type of like parasitic resistance. Does that look good? Our on resistance, so when it's closed, is very small resistance. It's like a wire. Our off is gonna be a fat, like it's closed, or it's an open circuit, right? A big fat resistor. Nothing's gonna go through that resistor, right? Let's run this. Oh yeah, I have other circuits I'll show you guys. You guys like these little previews I'm showing you? So here's our switch right here. Let me grab this. This is Model 3. Let me just put this to the side. Hello. Close that. I'll show you guys these other circuits, what I was trying to do. Boom. So I'm going to look at my switch. I'm going to color this blue because I like blue. So we just waited from 0 to 1 second, right? We're going on, right? Now it's on, right? Does that make sense? And then we're on for 5 seconds. So we're going from 1, 2, 3, 4, 5, 6, right? 5 seconds. And then we turn off. So what should we see at V out? It's going to be an open, right? It's not on. So let's watch this. Let me double click on that. I don't like these colors. Boom. So initially, let me just do this. Drag this little guy. Let me add another plot plane. Add traces. Add plot plane above. Here's my switch, right? We turned on this switch, right? So that means this should close, right? Here's our VN. I didn't even label VN. Let me just zoom in. You like that? Does that make sense? I'm gonna run this again so you guys can see VN. What's gonna be VN for all time? 10 volts. It's just on. So let me show you if I put V out and V in. Here's my switch. When the switch turns on, we just close this, right? What's V out? 10 volts. So that means V in and V out are closed together, right? And now after I turn off the switch, it goes down to 0. It's off now, right? What's V out? 0, right? Is everyone following what I'm trying to do? All right, now let me show you this other example that I was trying to show you. The other surprises I have. Let me see this one. Oh yeah, it's the same thing. Well, let me show you this other circuit I have. Lecture 4. You like that complicated circuit? You guys want me to walk through it? Let me show you. Don't want anyone going lost. So, let me just keep that there. I'll create another one. We're going to go from scratch. Do switch 1, switch 2. Here's my voltage supply. Wire. Boom, 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 boom. Does anyone got anything to say about these switches being tied like that? No? So what I'm trying to do is I'm trying to recreate this kind of switch. You're going to need a clothesline here and a clothesline there. So ideally they should, well, technically be both open. Does that make sense? So what I'm going to try and show you is the following. So let's do our resistor there, close, 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 boom, 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 ground. Oh, 10 volts. Let's do 100. Let's do 200. V1. Gonna call this one V2. And now I need the same thing over here. I'm gonna ground this. Is that anyone bothered when I do that? No, it's just connected to the port itself. So this one, I want it to be initially on. So I'm gonna call it V initially on, right? Does that look cool? I'm gonna do copy paste because that's our best friend. V initially off. Right? Is that clear? So now, let me just label this VN. Let's start declaring some stuff. Before that, I'm going to call this one, I don't know, switch 1, right? And then switch, I don't know, LOL. Like that? Anyways, let's define these switches by doing model, right? And we're gonna do our first switch, switch 1, which is of the class SW, R on. Let's do 0.1, right? Anyone bothered by that? R off is equal to 1 meg, or let's just do 1,000, or let's just do that. Is anyone bothered by that? V threshold is going to be 0.5 volts so that we can have like that switching from 0 to 1. Like that. I'm going to copy paste. Boom. And what did I call this one? LOL. Man, let me just do this. 1 gig. 1G. You like that? What about 5G? Who likes 5G antennas? Anyways, ready to simulate this? So initially, and then now someone's saying, hey, how do we turn these on? That's a great question. Let me just do a voltage supply, ground, wire, boom, 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 copy paste. Man, there we go. Pulse. So initially needs to be on, right? So 1 volt. Does that make sense? Then we're going to go to 0 volts, right? Let's do no delay. We're going to see it initially at times equal to 0. It's on, right? T rise, let's do 1 micro or 1 nanosecond. 1 nanosecond, 5 seconds, it's on. Is that good? Now I'm going to copy this whole thing. Boom. Initially off. Right? How do we turn this off? Make it behave the opposite. Just switch this around. Is that clear with everybody? You guys ready to simulate this? All right, let's run it. Let's do 10 seconds. All righties. Let's close this, close that, boom. And let's see them turn on. This should be initially on. It is not on. Why is it not on? Oh, I do need to have a delay. Let me see. Initially on from 0 to, it goes from 0, 1, 0. No. I guess I do need to have that delay. 1 second. There we go. Sorry, y'all. Let's add that 1 second delay. Roll them. Boom. There you go. Color, red. It's on, right? 1 volt. We're turning our switch on. Does that look good? Let's turn it off right here. You like that? So now if we take this voltage initially on, right, and put it right here, right? we should see that V1 should be closed, or this switch should turn on, and then it makes V1 equal to Vn. Is that correct? Let me make another plot plane. What's Vn? 10 volts. What's V1? Well, it's initially on. Sorry, that's what I meant to say. It's initially on. The switch is on. This is the wire that's on, right? So that means V1's going to be closed to Vn. 10 volts, right? Down to 0. Is that good? What about this other guy, V2? It's initially 0, right? So basically we did this cool switch. So now V1 is on, right? It's 10 volts. It's taking that 10 volts. V2 is taking 0 volts, right? And then we just did the switch. Let me just zoom in. You like that zoom in? Oh, I can't really do that. Anyways, zoom to fit. Does that make sense for your guys' homework if you guys have another switching problem? Is that clear? Anyways, then someone's probably asking, do I want to do that? Now that's literally the easiest way you can do a switch. This is how, and if you wanted another switch, you just copy paste this and then create another switch. Understood? All right, so let's go over some homework because I got a problem. Does everyone know how to do this? You guys want me to walk through this and give you guys confidence? All right, let's go then. So let me just write. Oh wait, before I even do that, let me just switch this. Let's do some real circuits. Okay. Got plus minus. There we go. Don't worry. Put a dot right there. And boom. Plus minus 24. 12 volts. And let me close this. All right, now let's do this as 3. This is 2. This is 4. And this right here is 6. Does that look good? And the problem is saying we want to probe, just do this, plus, minus. Oh, sorry. Let me just look at that. Does that look like your homework? Look good? You guys like this circuit? No? Want to make it easier? Right? What's the voltage over here? What's the voltage over here? 24? So, what's the first thing we got to do? What's that rules I was telling y'all about? 1. Draw currents. All right, let's do this. I'm gonna do it the following. You guys like that? Call this one I1. Good. What about this way? Like that? Step 2. Plus, minus on resistors. Is that good? So I'm going to follow this, and I'm going to be defining this resistor based on this I1. Plus, minus. Is that good? Plus, minus, right? Plus, minus. And then this one I'm just going to do plus, minus. Is that good with everybody? Step 3. Let's walk. Walk. There we go. Or KVL. Is that good? So I'm going to do the following. I'm going to draw my little person. We're going to walk around our little circuit. Is that good? Let's go up here. It's the first thing I see. I'm going up the stairs, right? I'm going up 24 volts. Right? So now I'm over here. Right? Which way should I go? Should I go this way or should I go on the 6 resistor? Oh, could be the same. Let's just go through here. So I'm going to go through here. I'm going to go down. But what's my current in this resistor? Let's define that because now Someone's probably going to ask that. Let's see. What marker should I use today, everybody? Let's see. I'm going to call this IR4. What's IR4? So the current, if I'm defining it going from this way, plus to minus, right? What's the current that's going through in terms of these loops? I1, right? The big loop right here, 1, right? What about I2? It's going against me, right? Does that make sense? So if I were to go down this, right? Let me just show this everyone. Use the orange marker. Going down the stairs, plus minus, IR2 or IR4, whatever this resistor is, right? IR, which is that 4. I'm just going to put a 4. Does that bother anybody? Like that? No? I'm going to do the same thing right here. Minus IR2 in that 2 ohm resistor times 2, right? So I'm walking around the circuit, right? I'm going to go down over here, right? Minus, what's the current in here? IR3, right? I'm just calling it a current, right? Does everyone like what I'm trying to do? Don't worry, we're doing it the long way, right? And now I'm over here, right? And now I got to go down the stairs right here with 12 volts. Minus 12 volts. And now I'm back on ground. Does everyone like what I just did? Now, why didn't I just skip steps? I'm trying to show you guys that your fundamentals. What's the current in this resistor? Well, it's just the current, whatever flows through that resistor. But it's going to be based off these two currents, these two mesh currents. This is what it's called. This right here is called a mesh currents. That's what these guys are. So you're meshing these currents to give you this total current going through that resistor, right? What can we say about the current in this resistor, right? What's that equal to? The same current that's going through this, right? It's going to make our math a lot easier in the end. So it's all based off in terms of I1 and I2. Is that understood? What about the current in there? Got I1 here, right? And it's going with the flow of our resistor. Does that make sense? IR3, the resistor in this 3 ohm resistor. Is that making sense, everybody? Then what else did I solve for? 1, 2, 3. Got 3 currents and 3 resistors, 2 voltage supplies. Is that good? Let's make this a little cleaner. This is page 2. I'll rewrite these circuits. 224 minus IR4, 4 minus IR2 times 2 minus IR3 times R3 or resistor 3 minus 12 volts is equal to 0. We set the current in IR4, right, is equal to this right here, right? Make sense? So let's just start plugging and chugging. I1, right, minus I2. Good? And then what is the current in this guy? We just define that over here, right? I1 minus I2 times 2, right? What's the current in this one? Right? 1, right? I1 times 3 minus 12 is equal to 0. Like that? Let's simplify it. So if I do the following, if I take this and this is going to equal 12, and like terms, these are 2 like terms right here, minus, let's see, 6 I1 minus I2, and let's grab my other marker, minus I1 or times 3. We're getting there, right? Now let's finally finish the circuit. So let's see, if I just do this 12 volts, do I want to skip steps? Is anyone going to be bothered if I do the following? Actually, no, I don't want to skip steps. Minus 6, or yeah, I don't like this. 12 minus 6I1, right? Plus 6I2, right? And this right here is minus 3I1 is equal to 0, right? Now let's make it to where it is easier for us. Let's do the following. Here's I1, here's I2, another I1, 12 minus 9I1 plus 6I2. Is that good? Which one should we solve for? I1 or I2? I1, because it's the first one. So if I do the following, minus 9I1 is equal to minus 6I2 minus 12. Does anyone bother if I do the following? Plus 6, 9, I2 plus 12 over 9. Is that good numbers? One equation. But we have two unknowns. We got to find the other unknown. So, let's see what we have here. This is page 3. Looking back at our circuit, right? We just did a KVL going through here, right? So now we got to do the other KVL over here. So I can either go up here to get this I2 one, or I can just do this little loop right here. What should I do? Should I walk in this circle? All right, let's do this. I'm going to rewrite this circuit. Make sure this is simple for everybody. X minus. Wait, hold up. I don't like that. Messy, right? This is 6. This is 2. This is 4. Does that look good? Now let's rewrite all these equations. You gotta keep all these signs the same, okay? So that when you're recreating your circuit again, don't think, oh, I can just do plus minus. No, don't do that. Let's try to keep everything the same relative to what you're trying to solve for, plus minus. And then this was a plus minus 3. This is 24. This is 12. Does that look like the same circuit we just did, right? And then let me just draw our currents. Whew. I2. I1, right? Where should I start? Start over here. Does anyone bother if I do that? Let's go this way. Does that bother anybody? Anyways, I'm going to go up, right? Minus the plus, we're going to go up a potential, right? I'm going up a potential, so that means it's going to be the resistance or the current here. I'm going to call it IR6, right? The resistance in that 6 ohm resistance, right? Times R, which is that. It's going to be a plus, okay? We're going up the stairs, okay? So now I'm over here, right? And we said we were going to go this way right here, right? Does that make sense? Then I'm going to go down this potential, right? So I'm going to go down IR4 times 4, right? Then I'm going to go down again. I'm over here. Minus IR2 times 2, right? And guess where I'm at? 0. I just came back to the same point. I went around this circuit. Does that make sense, KVL? We're all confident with that? So let's rewrite this. And this is page 4. Do this. Do this. So IR6, right? What's the current in this resistor right here relative to I2? Well, the resistance in this one, here's IR6. I'm going to show you this, right? Because I said plus to minus, right? I defined plus to minus where the current IR6 is going this way, right? So if I'm going against this, right, it's going to equal, does that make sense? Right? Should. Because plus to minus, I'm going this way. And IR2 is that. Plus to minus, no. IR6 should equal, hold up, give me a second. I need to think about this. Because if I'm going this way, right, IR4, I'm going down the stairs, right? But IR4 is equal to the mesh current of I1, right? We're going down this, right? Minus what's coming at us, right? Right? Plus to minus, right? Yes? So IR6, I just labeled it as plus to minus, right? But wait a second. I2 is going with IR6, right? So that means I'm wrong right here. Should actually be plus. Did everyone catch what I was trying to do, my mistake? So what I was thinking was, wait a second, I'm going against it, but because I'm going minus the plus, right, I'm going up, but IR6, the current in this resistor, I define it going that way, plus to minus, right? But relative to this, I2 is also following it. IR6 and IR2 or I2 are all in the same direction, so it's plus. Like that I caught my mistake? Let's find out. Anyways, so now that we defined this, right, and then we already defined IR4, right, is equal to I1 minus I2. Is that correct? And then the current in IR2, this resistor right here, right, it's also equal to that, right? Let's start plugging and chugging. So based on this equation over here, like that, it's going to be I2, 6I2, minus I1 minus I2, 4, minus I1 minus I2, 2 is equal to 0. Is that good? Ready to simplify this? So I'm going to do the following. 6I2 minus 4I1 plus 4I2, right? Minus 2I1 plus 2I2. Is that good? Is everyone following me? Let's look at like terms. I'm going to look at I2, I2, I2. So we got 6 plus 4, which is 10, plus 2 is 12, 12I2, right? Then let me just grab another color. I1 here, I1 there, minus 4I1 minus 2I1 is going to give us minus 6I1. Good? Is everyone following? Did I make a mistake? Not yet? So, remember that first equation we were looking at? Let me see if I can grab that. We solved for I1. Congratulations, right? But now we got to solve for this I2, right? But let's just say I want to punch in. We're going to punch into this equation. So what should I do? Solve for I2, correct? All right. So we want this. Good. 12I2 is equal to 6I1. Good. I2 is equal to, did I do it right? Did I get an A? Anyways, let me see. This is page 5. Let's do this, page 6. Oh, man. Are your guys' homeworks this big? Anyways, let's see. Let me rewrite the equations that we had from our previous page. So, we just solved for I1, right? I1 is equal to 6 over 9 I2 plus 12 over 9, right? And then I2 is just equal to 1/2 of I1, right? Is that looking good? So now I want to substitute this, and this, right? I'm gonna punch and plug and chug. I1 is equal to 6 over 9, 1/2 of I1, right? Is that good? Plus 12 over 9. Let's see. So if I were to do the following, this 6 divided by 2 is going to give us 3 over 9, right? Plus 12 over 9, right? I1. All I got to do is just put like terms together, this and this. Let's see. This is technically 9 over 9, right? So that means we got to do 9 minus 3 is equal to 6 over 9 I1, right? Is equal to 12 over 9, right? Let's see, 9 divided by 6 times 12 divided by 9. That cancels out, that cancels out, that cancels out to 2. Did I do it right? Like that? We just solved for I1. But wait, there's one more thing. What's I2? I think I solved it right. The numbers came out nice, right? Can we sing Kumbaya? So does that make sense? But now you're saying, hey David, I don't feel confident. I really don't know what's going on. I'm kind of scared. Don't worry. Actually, before we solve that, before I answer that question, we got the currents, right? But now you guys want this. You guys actually want the problem itself. What was the problem asking? VA, right? Let's do it. Let's see. Is anyone going to be bothered if I just do the following? No, I have to do the whole circuit. Someone's going to start complaining. Man. This is 12 volts, right? This is 24 volts, right? It's at a higher potential because I drew it higher. 3. This is 2. This is 4. This is 6. Let's bring back the same nice turquoise color. Yeah, this is turquoise. Plus, minus, right? So is anyone going to be bothered if I call it V4, the voltage drop, or actually VD4, voltage drop at 4? I'm just calling this a number, right? Is anyone bothered by that? No? I'm going to call this one VD2, right? And then this right here, I like my colors. It's calling me VD3. There's just the voltage drop at that resistor, right? Who's ready to walk the circuit again? Like that. I'm going to go up the stairs, right? 24 volts. I'm over here, right? Now I'm going to go down the stairs, right? Plus, minus, right? Minus VD4. Now I'm going to do the following. I don't know, A to B. 0, or this is A to B. Was A to B? No, this was VA, A right there, right? This is B, right? So let me show you this. Is anyone bothered that I just did VA to B right there? Just equals VAB? Is anyone bothered by that at all? So the way we do KVL is if I'm here, right, that's 0 volts, right? I just did 0 volts. But when I go up the stairs, right, what's the voltage over here? 24 volts, right? So I walk up the stairs and I say, hey, with this being ground, right, what's the voltage at this node? What floor are you on? The 24th floor, right? Does that make sense? I'm going down the stairs, right? So I want to know what floor I'm at, right? So if I just subtract the voltage drop, I'll know what that floor is relative to the ground. So what's VD4? It's going to be IR4, right? The current in that resistor, right? Times, well, the resistance, right? But what did we just say IR4 was? I1 minus I2, right? From the very beginning. But what was I1? 2, right? And what was I2? Just half of I2 is, well, actually, I1 is 2, and then I2 is 1, right? So what's IR4? Just 1, right? Guys feeling good? So that means if I were to rewrite this again, 24 minus 1, that's the current, right? Times 4, right? What's VAB? Any questions about that? Now let's go back to the question of, I don't feel confident, man. I really don't know. This is tough. That's where LTSpice comes into play. LTSpice is a beautiful calculator that helps you with any circuit. Let's prove it. So let me just do the following. Let me save this. Save as 220 2 switch. Here we go. Close this puppy. 1 switch. No, is this? What is this one? Close this one. Yeah, sure. Which one should I give you guys? I'll give you guys this one. Save as 1 switch. I'll show you guys these files so you guys can feel happy, go home, do your homeworks. All right, let's copy this because I want to go over some more things. Boom, boom. Who's ready to see my magic? Boom, boom. There isn't no magic, just engineering. Unless you know it, then you can make it magic. Boom, boom, boom. And we're doing a calculation. We're calculating any circuit. We're going to calculate this answer right now so you can give this to Dr. Zoo or Dr. Pushkin and be like, I did it. I'm confident. I'm feeling good. I'm going to get an A on that exam. So let's do 12 volts. Let's do 24 volts. Let's call this one VAB. Right? That's what you guys wanted? And then I'm going to call this one, I don't know. Oh, yeah, V2. Wait a second. No, I don't like this one. Yeah, whatever. V2. This one's technically V1. That's why I said, wait a second. I'm going to call this one, I don't know. Call it V. Oh. You like that? Who's ready to solve this? Okay. 3, 2, 4, and 6. All right, you ready? So I'm gonna run, and you can do it transient. I like transients because nice, funny colors. I'm gonna do 1 second. Just run the circuit. That's it. What's our voltage right here? 24, right? Oh, you like that? 24 volts. What's the voltage over here? 12. You like that? Feeling good? We just said the voltage at VAB is 20, right? Let's see if I was right. Oh, baby, let's go. Feel good? Now you guys feeling more confident with your homeworks? Did anyone know that you can do this on LTSpice? After this, does everyone feel more confident that, wow, I can calculate any circuit, mesh, or what do you call it, nodal analysis, any of those kinds of circuits, switching circuits? Does that make it clear? Let's see if I got the currents right. The current I1, did I make that circuit? I made the current go this way. So here's the funny thing. Does anyone bother if I just click this resistor? 2 amps, right? Flowing down, right? We just made that loop going down, right? Does that look good? And then, oh, it's in the same direction. I'm gonna click on this. Let me just make another plot. Add plot plane above. Current here, current there, boom. 2 amps going through R1. Which one's R1? This, right? Yeah. Which one's R4? This one right here, right? I should have just labeled these. Let me see. Does anyone bother if I do this? R3. Then I'm going to call this one R4. R4. Oh, man, this is great. You guys are getting lots of free education. Run this. Boom, boom. IR4. 1 amp, right? What's the current in IR2? 1 amp. R6. Man, you guys did it. Oh, I don't know. We all did it. Is this making sense for everyone? You guys going to be confident for the homeworks? All right. And what other questions? Because I think that was one of them, right? And then I guess this was a solution, I guess, from what I was seeing. Let me see. Someone else sent me something else. What was another question that someone was having? Yes?
Is there a way to reverse the current yourself? That one is going the other way.
Oh, it's going the other way. Well, you can. Let me show you this. You can do it 2 ways. You see how the arrow's pointing that way, right? I'm going to press the M button for move. See, wiggle it around. I'm going to do Control R. And then I'm going to do the same thing right here. M for move, Ramon. Control R. I'm going to run this again. And boom. The arrow's going that way, right? 1 amp, minus 1 amp, right? Boom, another minus 1 amp. And then you wanted to verify the current in this one, right? But it's positive too, right? You see this arrow? It tells you. So if I do M, boom, 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 run. Now it's minus 2. Is that making everyone feel confident about what's going on? What other questions do we have for the next, technically we have 3 minutes. How's the classes going? Finally got your guys' textbook. Got the problems. Let me see. 2, 4. Actually, let's talk about these problems. We're going to skim this really quick. If a light bulb is rated 60 watts at 120 volts, what's the resistance? You got P is equal to IV, right? But V or I is equal to, well, V over R, right? There's the answer. Boom. Does everyone make sense? Man, what homework is... this is the first time I'm seeing this. KCL, right? Find V1 and V2, voltage drop. You guys are confident with that? Find the current in this. You know the resistance. Oh, find V1 and V2 for the following circuit. You have this voltage. You have this voltage, this voltage. You guys want me to try this one? No? This is not that bad, right? No? What other problems did he give you? Oh, someone gave me a problem. Let me see. Oh, I remember now. Where's my cell phone? I'm going to use it during class. File Explorer. Aha, got it. We're going to go over this one. This one should be easy. What page was this? 7? Then I'm going to do one quickie problem. Boom. This is page 8. So I'm given the following. Boom, boom, boom. Guys like my resistors? They're ugly. Like that. And we're trying to solve for R equivalent, right? So we're trying to transform this into something like this. That makes sense? So let's see. We got R right here. We got 2. We got 6. We got 5. We got 1. Let's see. This right here is in parallel with this. R and 2R, right? Let's solve this. Call this right here. Boom. Boom. I'm going to combine these two right here. What's the parallel resistance with this? 2 times R over 2 plus R. Does that make sense? I'm going to call this one, I don't know, RP, right? RP. Yeah, RP. Right? Is that good? 5, 6, 1, right? Let me see. Because eventually what they want is solve for the resistance to make it equal 4. We want this all to equal 4. I want this to equal 4. So let me see. RP. We have that. I'm going to solve for this right here. Does anyone bother if I do this? We got to get going. I'm going to combine these two right here. Does anyone bother by that? 6. This right here is just RP plus 5, right? Is that good? Now you got to do the parallel resistance of this again to get, just draw a different color. RP plus 5 times 6 over RP plus 5 plus 6, right? Is that good? Then all you got to do is just plus this 1. So that means our REQ is going to equal 1 plus RP plus 5 times 6 RP plus, let's add these two, 11. And then REQ, we want it to be 4, right? Solve for RP, and then once you solve for RP, solve for R. Does that make sense? Is this easy homework? Yes? Oh. Is that good? So we just want to solve, we want to force this. They gave us an answer. We want 4. So all we got to do is solve for RP, right? Once you solve for RP, you just solve for R, and you're done. Easy? Any questions? Yes, we have discussion next week. All right. Have a good day, everybody.